Should be about now.
That's it.
Hey there, everybody. Welcome to the new year, 2023. It's our 98th episode of the SBAU Astronomical Unit, our weekly blog podcast on Monday mornings. I'm Ron Heron on the board. It's 11 to noon every Monday. We call the SBAU gang together. If you happen to be a fascinated fan of all this stuff going on in space these days, listen, come join us. NASA probes, launches, checking out the night sky, new discoveries in astrophysics. And by golly, it's 2023. We had a great meeting on Friday night. We'll talk about that. We're also going to meet the gang here in a second. And this hour, we're going to try to talk about what's up with our current comet, number E3 out there, ice volcanoes on the moon, Enceladus. I have trouble saying that. That's going around Saturn, right?
Yes.
Don't have a lot on that, but we got some great pictures. Blazing black holes. My God, it sounds like a Mel Brooks movie. Blaze our saddles. A cometary globule next to the galaxy and a cluster of clusters, and more on Mars's wet past and dreaded magnetars. My God. SBAU.org can tell you how to see Chuck's great Friday night sports talk on occulting in the middle of the night. As we get the gang together, we even have a German cartoon we're going to see in a minute. But let's meet the gang. Jerry Wilson, president, looks like for life. And welcome aboard.
Good morning.
We got elected again 2 months ago, didn't we?
Uh-huh.
You were at home. You weren't even there, but you had a good excuse. Wife is Pat Forgy of the Forgy Wilson Company. We have our incredible, outrageously outreachable outreach coordinator, Chuck McPartland, in front of the Ukraine flag. He's married to our beautiful merchandise manager, Pat. They're both married to a Pat. Tom Whittemore, you married a Maureen.
Maureen, yeah, good morning.
Quit a great job at former Westmont College, but look at the color of his hair. He was ready. And my name's Ron Heron. I'm the only one that doesn't have a lady with me, but that's okay. I got the same rain you guys got. And we got, real quickly, some outreach stuff, Tom. Or Chuck, what are we going to look forward to? One cancellation, I know, right?
Well, we already, for the 12th here on Thursday, we got canceled for Providence School. And coming up on Saturday for the second Saturday at the museum, it looks like that's probably down the tube also with rain. But that's all right. We need the rain.
Yeah.
Okay. Well, we also need some levity with this rain and all, and that's where the president finds somehow on the internet these silly science cartoons and sends them to us. One of them in German this week, which we'll translate for you. But it's still okay. What's this one? Is this It Matters? No.
Yes.
They're being watched from way above. Honey, which dress, red or blue? So they're talking. That's got to be Chuck and Pat. No, Janet.
It says Janet.
Okay, Janet, it doesn't matter. And then up in space, there's two aliens sitting in the spacecraft. If she goes with blue, I'm totally blowing it up. Okay.
So her choice does matter.
What does matter? I didn't get it.
Her choice.
Oh. Okay, is that the old UNIVAC? Is that an early?
Or ENIAC.
It looks like ENIAC, but it could be.
All right, and years ago, we have the guy telling the couple visiting, someday we'll be able to hold one of these in the palm of your hand while you poop. You ever had to take
this reminds me of I started working with computers in 1963 when I worked with a Sperry UNIVAC.
Did you really?
It wasn't that big, but it was still a big lunker.
Jerry, do you remember the PDP-11?
Yeah, that came later.
Yeah, I worked with one of those at Arizona.
Yeah.
Should have saved all your floppy disks and cassette decks.
This was tape read. You put a tape in.
Yeah. UNIVAC was done by switches.
Okay.
Is it true that our modern day iPhones are better than what they had in Apollo 11? Pretty much.
Oh yes.
Oh, absolutely. A 4-function calculator is probably better.
Yeah. And one more, Jerry. Do you remember the Altair 8800?
No, never worked with one of
Okay.
those.
That was switches. Chuck probably remembers that one.
Yeah,
All
well,
right.
no, I have an IMSI 8080, which was contemporaneous with that.
Oh, okay.
You'd load it with paper tape.
Mr. President, you're going to have to explain this one. Fred, there's an unplugged Ethernet cable. Go fix it.
Ethernet.
Ethernet. Is that from the past?
Ethernet.
Ethernet.
It's a way of
Ethernet.
connecting.
Ether with a, okay. But what's the picture of? Are we looking down a?
You are
that's the
looking at
webcam.
a massive tangle of connection cables,
Oh,
and one of them is bad. So you got to go fix it.
Okay, I got it. A nightmare for a handyman.
Yeah,
Okay.
looks like a spaghetti fest.
All right, here's the repairman in the shop telling the belated owner of the time machine, I'm gonna have to order a part. Should take about 400 years. They haven't made them yet or invented them. Time machines. Can you blow that up a little? Ah, this is how in 1869, you blew it up too much. I got it cut there. Dmitry Mendeleev completed the first periodic table. And something's missing, or that looks pretty close.
This is a screenshot mimicking a game Tetris.
No.
Oh.
Something appears and comes down, and you have to orient it right and move it right so it fits into a vacancy.
I see.
So it's implying that he was playing a computer game.
Gotcha. If you kept blowing it up, would we be able to see the names of the elements in those?
I don't think it's that high resolution, no.
All right, well, then we won't try, but that upside down L is rare earths, I'm sure. Here we go. In the ancient times, caveman era, the deal is you got to reverse these two, right?
Well, it took me a while to figure it out.
Yeah, it did me too. Tom Whittemore, can you figure this out, what the problem is?
It's the problem he's complaining about.
Yeah,
Yeah.
yes,
Just reverse the two boxes and it makes sense.
right.
It's a time machine thing, time warp, if you
Yeah,
will.
this frame actually comes before this frame because his time machine is not working, because it goes off randomly sometimes.
If they ever do invent time machines and we go back, we're gonna find ourselves in dark, empty space, aren't we? That's where the Earth was.
Don't account for motion, yes, but I'm not sure there's a reference frame to tie yourself to without the Earth, but
Distant quasars.
that didn't come out right.
Here's the German one. Anybody want to read the German?
Yeah.
You
I
not
can-
total? Go
Not
ahead.
told, der Koffer is weg. Yeah, the suitcase is gone. It's just gone. Yeah.
He's opening.
Not told. I don't know that. It's probably some swear word or something.
Somebody on the moon stripped the limb.
Well, Bruce sent a translation. It was something like, "Oh, good, my suitcase is missing."
Yeah,
Yeah.
Okay. So this one didn't get.
Yeah, it's pretty-
Yeah, it came under the heading of my suitcase is stolen. And
Oh, okay.
Bruce is right, Vegas missing.
Yeah, it's just
Oh.
gone. Just gone. Yeah.
Well, just out of curiosity, how many of those landers without the part on top are still on the moon? 6, 7, scattered around different places?
Well,
About that
6.
number, yeah.
Suppose we'll ever get them? Go pick them up?
What for? They're litter now.
Yeah. There's valuable information when you leave things on the moon like that. One of the Apollo landers landed near an earlier Viking lander or something.
Surveyor.
What it was called? What, Surveyor?
There, yeah.
And they went over with bolt cutters and they cut off several cables and brought it back. And
Did
that
they
gave
really?
us, what's that?
Really? I didn't hear that.
They brought back a camera that was on one of the surveyors.
Right. And they looked at the insulation under proton bombardment from the sun had turned to powder. So materials behave differently in space, both because of the vacuum and because of the radiation that's there. And that's very valuable information. It was also found out that tin grows, I think it's tin or zinc. If you
It's tin.
plate your screws with one of those, then in a vacuum, it grows whiskers. And the whiskers grow up and they touch something else, then they short out. So you can't
doesn't
use
even-
certain
It doesn't
materials.
even have to be in a vacuum. It'll just happen like high tin solder used to do that and cause all kinds of problems in
Yeah.
electronic devices.
But
Yeah,
we,
by the way, guys, I just looked up the translation of not told. Oh, great. Oh,
Oh,
great.
great. Okay.
Okay,
And
okay.
it's got to be real colloquial. That never showed up in my 2 years of German.
so there's a briefcase, not a spare. There's no wheels on the
Yeah,
end.
a coffer could be a case, a briefcase. In Vegas, it's gone.
Yep.
It's gone.
So now he's not going to be able to get to his pajamas when he needs.
Yeah.
But to answer one last question, that surveyor, it didn't crash on the moon. Did we land it earlier?
Mhm.
It was
Yeah.
one of the first soft landings.
Yeah,
Okay. A precursor to the Apollo program, I guess.
Yeah.
After Gemini. Got any more sillies, Mr. President? Oh, here we go. This one you're going to have to explain. Oh, let's kind of.
everybody who's been out at a remote site, set up their telescope and is ready to take pictures with it will understand this instantly.
Okay, got it right. That looks like.
He's
Chuck's setup.
frowning, something didn't work. So this is a mini version of that first joke with the cables. Find it, which one is not working? So he's got his laptop here. He's got some kind of an instrument. He's got a battery source, camera, tracker. He's got 2 trackers.
Yeah, wow.
And he's lost. Big question mark.
He's got to troubleshoot it now in the middle of the night.
Yeah, and I think his the other thing on top of that, Jerry, is backwards. Did you see that?
No, I didn't see that. Let me go
Yeah,
back.
Yeah, take a look at that. That's Chuck,
Tractor-
who makes those? I have one on my scope. You'll see it.
Well, we've
Yeah,
got-
there's a red finder. What's
Right.
that?
It looks like it's backwards to me.
Yeah, it is.
Yeah, okay.
Is it? I'm not sure. Well, yeah. Okay.
I think it is, Chuck.
Yeah.
We're talking about the little purple thing.
Yeah, it's the little instrument on top of the other see-through finder scope.
Yeah, the black thing right there.
Yeah, that's backwards.
Looks like a catalytic converter. Maybe it's
Oh,
It's-
no,
it's
Well, not the telescope, the thing above the telescope.
that thing. Yeah, it's backwards.
Yeah,
that's the tracker.
No,
No,
that's the optical finder.
yeah, it's a red spot finder. You look through it and it superimposes a red laser spot on the image
Right.
of the sky that you see.
Yeah,
Really?
it's single power, also single power. So
Yeah,
mhm.
Somehow that directs you to the star, put it right in mid.
Well, Ron, it's like a head-up display that displays either crosshairs or circles.
Yeah,
Oh, I see. All right.
it's backwards.
None of that is on your regular lenses or mirrors.
No,
No,
but
it sits on the outside and you just look through it.
right. Yeah, for my 8-inch telescope, I hang one of those on top for outreach.
It's called a Telrad, the usual.
Telrad.
one.
that's it. I was trying to think of that name. Thanks.
Anybody know what happened to spam collector, Mr. Murdoch? He's not available today. Let's look at this.
He
I'm
might
sure
be
if he was
bailing out.
available,
Say again?
I'm sure if he was available, he'd be here.
Yeah,
Yeah.
it's true. You're right.
Oh, there he is.
Oh,
yeah.
he just joined us.
So this is a
Wow.
picture of a ruptured globule, an accident of superposition that makes it look like it's sneaking up on and about to swallow a galaxy.
Pretty good.
Reminds me of one of the first season Star Trek
Yep.
episodes back in the 70s.
Mhm.
So
My doctor just told me I had a ruptured globule, but we'll work on it. Go ahead.
well, these globules are an early stage in the formation of stars. They're usually not ruptured. They usually have a dark head and they look like a comet sometimes with a dark head and then a trailing dark dense dust behind them. And they're a collapsing I guess, collection or cloud of dust that is forming a star. This one is illuminated inside and it's ruptured. And my guess, and this is just my own view, is that a star or stars have formed inside, and now there is a strong stellar wind that is blowing the dust away.
Wow.
So,
Well, stellar wind would come from one star, wouldn't it?
yes,
Or multiple ones.
yeah, but when stars form, they form in groups in a nebula. You find in the Orion Nebula, in the Rosette Nebula, with amateur instruments, you can see high resolution, you can see Bok globules, BOK,
Mhm.
an astronomer that named them, or they're named after him. But you can see
Yeah.
globules.
Bart
What's that?
Bach.
Barton J. Bark?
No,
Bach?
Bart Bach. He was at Arizona.
Yeah, okay. And you can see these globules, there's many of them around, and inside and you can see little clusters of stars that are there when one of these made stars, and it's a stage. When stars get born, they turn on, the dust collapses, it compresses and gets hot, and when the core temperature goes over 10 million degrees Kelvin, then nuclear fusion starts. The star turns on, and now it has a strong outward radiation pressure or a stellar wind. And that wind starts blowing the dust away so that it doesn't keep adding to the star.
Yeah.
And you'll get a number of them, and they don't just form one star, they'll form a whole bunch of stars in there. And the combined wind, stellar wind, can blow the remaining dust away and disperse it throughout the region.
Yeah. I was going to say, Jerry, completely unrelated, but just below and to the left of that galaxy is the most perfect circle of stars I've ever.
Oh, you're right.
Oh, you're kidding me. Is that accurate? Is this a real picture?
That's actually the dentures of the shark on the right that's trying to swallow the galaxy.
Yeah,
Yeah,
that's pretty good.
good spot.
Okay, why do they call it the cometary globule?
They call it that because they're usually, this one is not terribly cometary, but it has usually a head, which is rough in this case, and then it has a trailing region behind it that makes it look vaguely like a cometary tail.
Like the tail.
Yeah,
So
but
all
it does
that,
not act like a comet.
but all that dust being blown away means no exoplanets are in it. That would have made those, right?
No, the exoplanets are all, they have the new stars have dust rings around them.
Oh,
And the interacting with the new stellar wind is causing concentrations of dust that is forming protoplanets.
but the globule is in our galaxy, and that little galaxy to the left is way out there beyond, right? They're not close
This
at all.
this one is in our galaxy. This one is way beyond Andromeda.
What kind
And
of
Ron, there may have been planets or planetesimals that have formed in that dust cloud that just aren't associated with a star that are getting blown back now too.
Yeah. Yep.
whoa?
Yeah. Some of the dust concretions didn't have enough mass in them to form a star. They just form a dark object.
And so they become rogue planets
Yes.
running through the galaxy in the dark and cold. My God. Is there a way you can put a degree number on this? Or are they a half a degree apart like the moon, or 2 degrees apart?
These are small objects.
Yeah. This is probably in an amateur scope. This is probably at most one arc minute.
Oh, an arc minute.
Yeah. One arc minute. Yeah.
They are close. Oh, okay.
Wow.
This is probably about the size of the deep field that Hubble and Webb both.
No, this is not that high magnification.
Mhm.
Well, I know that, but I'm talking about the size of the sky. It looks like
This is not that high magnification.
No.
it isn't. All right. What's
The deep field would be something, a little square deep inside this circle that Tom spotted.
Oh, that's not an asterism.
Yeah,
This is an asterism.
It doesn't have a name though.
It's a pattern of stars. This is the Baron von Herren asterism.
I thought it was a shark stitchers.
There's a lot. If you play with your mind, when I was a little kid, we had plaster ceilings that were hand plastered, hand rubbed. They were left semi rough. And when I was bored and had to take a nap, Mother pointed out to me that I could look and study the ceiling, and I could spot patterns in the ceiling, like mouths and faces and stuff. And if you sit and play here, because the human mind has that thing, looks for patterns. But here's a nice little triangle right there.
Mhm.
And if you start playing with this, you can find all sorts of things. There's maybe a spiral. There's a
It's
galaxy in the background.
There's
Yeah.
two interacting galaxies down below the cometary globule to the right too. Yeah.
I wasn't sure what that was. It looks like it might be a couple of galaxies, yeah.
Yeah, if you blow it way up, it looks kind of that way.
Oh, I can't move it around. Oh, there it is. Yeah,
Would we be able to see this in our telescopes?
I don't know.
I think so.
In that color?
I think, well, no, you'd have to apply your own color, but I think I've seen amateur images of this object.
You can certainly see Bach globules, which are on this scale, in pictures you take of the Orion Nebula or the Rosette Nebula.
Looks like the galaxy in the distance is about to be gobbled up by Pac-Man is what it looks like.
That's what the Star Trek episode had. This was a planet killer. And the Earth, the little sphere out here.
Well, obviously that distant galaxy is edge on, right? It's not the cigar, is it?
No, it's not the cigar.
No.
It is tilted a little to our angle. Yeah.
Okay. Fascinating stuff. Cometary
Yeah.
globule. It's C60, CG4, is that?
And there's a number 6.
Yeah.
What's number 6? I missed
I
that.
think it's a 5, Jerry.
Yeah.
Oh, you're 5. You're right. At 5 is better.
Okay. Well, your assignment, Bruce Murdoch, is to go out and try to find that and photograph it with your telescope. All right, let us know how.
Well, that's a little hard to do today.
Right.
Yeah. It would have to be a radio or an X-ray telescope.
Now, these are
Night sky
pictures
is
of,
not- Where I live, the night sky has not been that great.
No.
We get a thin layer of clouds up there. The moon doesn't look crisp. It's got a big halo around it. And,
well, how's the rain at your place right now?
oh, it really came down this morning, big time.
Yeah.
Sound
Still
like
coming
thunder.
down, yeah. This is it. Ice volcanoes on Enceladus.
Yes. This is one of Saturn's moons, and despite the ripples and craters on the surface, it has lots of plains on it and flat areas. And it's one of those moons that shows geysers. You can see the water coming out here from cracks. So there's a lot of emergency sirens out here. This is the structure that has been determined from satellite. What was the one? Cassini, that went around, and you can based on the shape, the detailed shape of the orbit as it goes by, you can map the gravitational field of objects that it flies near, and you can reduce the shape of the object, the distribution of mass in the object, and you can match that up with different molecular weight particles that are likely to be there. And this is the structure that has been deduced for Enceladus. It's basically a core of rock. It's surrounded by liquid ocean, which is the blue. And I don't know about the shades of blue here, but the ice layer on the top is this white layer, and it's thinner at the South Pole, and it fluctuates in thickness throughout the region up here. It is
Liquid underneath?
Yes.
the ice shell is roughly 20 kilometers on average.
Oh, 20
So
kilometers.
that sets the scale of this. Now, these features down here come from, let's move to the next thing there. This is a modeled feature fissure in the surface. Here is the ice shell. This is the outer surface, and this is the jet that we see coming out. It consists of ice particles, 1 micron in radius, and they reach escape velocity. There are large particles that follow a ballistic trajectory. Then there's free molecular gas on the millimeter size range above the surface. You
Well,
get,
wait, that's not 10 to the -3, Jerry. That's 10 to the
Oh.
third.
you're right, that's a height above the surface, excuse me,
Yeah.
3,000 meters. I go over all this before and make sure to practice it so I don't make stupid mistakes like that. Doesn't work. So you get a supersonic gas flow right at the top. The reason this all works like this is it's pumping to make these volcanoes, ice volcanoes. It's not an ice volcano, it's a jet. But the same reason that you get this jet is while you get the ocean liquid water down here, it's because of a pumping effect from the tidal forces of being close to the parent body, Saturn, but outside of the Roche limit that would actually tear the moon apart. So it's like tides on Earth. The pull of the Saturn causes this fissure to open and close. And that's pumping water up from down below, where it actually reaches boiling in here. Temperature is 273 degrees Kelvin. That's room temperature here. That's about 0 degrees Celsius. Is that right? Yeah, that's right.
Yep.
And this is 1,000 meters below the surface, below this surface. And up here is vapor and ice particles. And as it goes up and the crack widens and closes, it pumps this stuff out. And the ice molecule, the particles, the smaller particles, actually reach a supersonic gas flow.
Huh. Did your picture a moment ago of the moon itself show all these fissures on the poles, the bottom pole, for example?
This is, yeah, they're viewed on just the South Pole here.
Okay, right.
As
And
I
actually,
recall,
on Enceladus, they are concentrated on the one pole.
yeah.
In the visual image of it, you can see these fissures. They call them tiger stripes. And it's not just Saturn's gravity. It also syncs up, the moons are in these integer ratios and there's Titan out there. So those other moons are also contributing to the tidal forces.
So science is hoping there's some kind of life under those shells. And if there is, those little microbes are being spewed into space.
I don't know if they're hoping, but the comment is that life as we know it is associated with water. So where there's water, there might be life. And that's, we want to test that.
And chances are the
How do
water
you
is,
get oxygen into that water?
well, it's probably salty.
Well, not only that, but the atmosphere of Enceladus does it contain oxygen?
No,
So
I mean,
it'd be
there's
not-
oxygen in the water if it dissociates from ultraviolet light, but there's not enough gravity to make it hang around.
Yeah, I
Okay.
think the first life on Earth was anaerobic. It didn't need oxygen.
Yeah.
It was, and the bacteria actually produced the oxygen that we see, and that killed off the first generation of bacteria.
Ah,
But
well, you got
sodium,
two worms, they live on sulfur.
Yeah, that's right.
And you could have stuff like that going on in the rocky core there. There could be vents like we have at the bottom of our oceans too.
but like our oceans, it's probably filled with sodium chloride. That's got to be a pretty common compound in
The
planets.
salt doesn't mean just table salt.
Yeah.
There's a range of materials that are ionically bound and called salts.
Like on Europa, where you see where it says, oh, there's salt that's been spewed out of its cryovolcanoes that they usually color as kind of reddish on the surface. Those are magnesium and sulfate salts, not necessarily sodium salts.
And there's also potassium salts and
Right.
or sodium salts.
Yeah.
The
Right.
solid core of this is just featureless here. But as someone, I think Chuck just pointed out, there may be fissures and cracks in here because this would be subject to tidal forces and fluctuations of squeezing and relaxation that could produce vents at the surface, such as we have at our deep oceans.
Well, do you suppose moons?
A fluid core, a hot core?
Pardon?
Do you think that Enceladus has a liquid core, a hot core, a molten core?
I don't know. Certainly it has enough heat generated to produce liquid water. So
Okay, so
it may
probably
be,
does.
I don't know what the composition is. I'm not sure that, I haven't read anything about what is in the core. They just say it's a rocky core.
Yeah, I don't know if they got enough gravimetric data to figure that out, but here they're concentrating on the liquid ocean.
Yes.
Good chance though. It's like 250 miles across, I think, this moon.
Mhm.
Fascinating stuff, gentlemen. It really is. Now, are there any moons in the solar system that have electromagnetic field, that have any magnetism to them? Fields of force?
Good question. I don't think so.
So
It depends what you want to, certainly not on the scale of the Earth's magnetic field or Jupiter or Saturn's magnetic field. But even the moon has a very, very teeny tiny magnetic field in certain regions locally.
Best bet would be a moon like Io that's volcanically active, so it probably has molten stuff like molten sulfur in its core, and that stuff might be conductive and generate some sort of field.
otherwise, sulfur doesn't conduct. It's like plastic or silicone.
Ionized sulfur conducts.
Yes.
And
Anything almost conducts.
what's that, Chris?
Pardon?
Say again?
I said ionized anything almost conducts.
Yes. Yeah.
Well, there's different layers of ice that becomes something totally different when it's way down deep and very compressed.
There are
That's a
different
crystal
phases of ice. Some ices are stronger than steel
Really?
and proposed as structural materials on some of the colder moons and dwarf planets, at least in science fiction stories.
But I was
science fiction.
okay. I was corrected in my December early speech by, I think you, Chuck, saying that water doesn't really conduct electricity. It's the minerals in it.
That was Tom Totten, yeah.
Right.
Water is an insulator, and it's got a very high dielectric constant. It's 80.
Well, just try telling that to somebody in a bathtub when the radio falls in.
Yeah, but he's got
Because it's
mineral
not pure
salts.
water.
He's got bath salts in with him.
That's what it is.
He's doomed.
Actually, there was a this is a little off topic, but there was a proposal in World War II to make an aircraft carrier out of ice.
Oh, for crying out loud.
Not just ice.
Ice and sawdust, I think they were going to mix in with it. And it was called Project Habakkuk. And they actually tried making some structures and things out of it, and they decided, yeah, too much trouble.
Well, they'd never sail into the tropics, would they?
Well, that's why the sawdust was there, to try to insulate it.
Oh, is that right? Okay.
Well,
maybe
you
this
saw
is
this in the 1800s when they had ice houses and they would store winter ice for summer use. They put sawdust over it.
Yeah. They're some very clever designs to cool things off and store ice. The ancients.
What are we looking at now?
creative.
Jerry, can you tell us what this picture is we're seeing?
This is an illustration and not a photograph. This is of a blazar, a
Oh,
black hole that produces a blaze of light. It's like one of the speakers at our club Fridays many years ago likened this to a styrofoam ball with a flashlight jammed into it at an odd angle and then rotated around. So the flashlight would beam around as the object turned on its axis. And that's a physical description of what a blazar is. But where it gets the light is what they're trying to figure out. There have been two methods that were proposed about how magnetic fields might accelerate the particles and the beam. And they're trying to figure out the energy source for that. Now, a lot of the energy source for our sun spewing things out comes from the magnetic fields on the sun breaking and then recombining, which releases a lot of energy and spews things out. That was one candidate. Another option is that there's a shock wave that part goes down the jet, where there's like a phase change in the magnetic field where it goes from turbulent to non-turbulent or laminar. And that produces a shock wave that then sends this radiation out. And the result of a study done by looking at imaging X-ray polarimetry data from the IXP, the Imaging X-ray Polarimeter Explorer. They can see the polarization of the X-rays down close to the core or close to the source. And the data fits the second model, where it's not like our sun generates the energy to spew particles and stuff out. It's like the shockwave idea.
Are we talking about an accretion disk around a black hole?
No, we're not talking about, this is not a black.
This
Yes,
is a
it-
blazar. Yeah, it's a black
Yeah.
hole, but this is
Yeah,
the
it's a
jet, not
blazar.
the disk.
Yeah, we're talking about the disk, not the black hole. Nothing comes out of the black hole.
But we're talking about the jet.
Yeah,
Oh, you mean they sometimes come out of the poles
Yeah.
yeah.
And in this case, the jet is pointed towards us. That's what makes it a blazar.
and they're all spinning pretty much, right?
Yeah.
So if we got hit by that jet, would it, even from this distance,
Well,
fry
we are
us?
getting hit by the jet. That's why it's a blazar.
Yeah,
But it has nothing to do with stuff being sucked in.
Well, it's stuff that was being sucked in, but it couldn't go down the drain, sort of, and so it ends up getting launched out.
It's synchrotron radiation, right?
Some of it is, but this is more magnetic fields twisted up and accelerating this stuff away.
Well, that's what synchrotrons do.
well,
yeah, but that's,
synchrotron radiation is when you accelerate a particle to the side, and the radiation goes down the original path of the particle.
yeah, or when you go supersonic,
Yeah,
in effect.
It's got to be very confusing to today's kids at school to be told over and over again, nothing can escape from a black hole, even light. It's black and it sucks it all in. And then here we're learning all the stuff that comes out of it.
Well,
actually,
it
it
doesn't come out of the
no.
black hole. It never gets into the black hole.
right.
And it goes away from the black hole. The black hole
This is like a crowded theater, and some idiot yells fire, and everybody gets up and tries to run for the one single door at the exit, and they all jam up, and a lot of people bounce off of the crowd. That's exactly what's happening here. They can't get through the aperture.
Well, it wouldn't be
They bump into each other. It creates a lot of friction, creates a lot of energy, and that causes them to expand and blow out.
it would still be very dangerous to try to get thrown out that way. If you were in a rocket ship, you'd be fried by the gamma.
It would throw out your atoms one at a time.
I don't know. I think I'd prefer to go in and see what's behind that damn event horizon.
Yeah, but you can't send any information back.
That's okay. I'd at least know.
I think we discussed this before, but the 2022 Nobel Prize in Physics was awarded to three gentlemen that the names escape me, but they proved that
One jury was, I
was wrong. That
think one was Elaine Constant. the French-
okay,
Yeah.
It proved
they
what?
proved that particles in our universe are not locally real. To summarize it, now that brings up a problem of, and we discussed this before. Now I'm recalling that information is not lost in our universe, and if information goes into the black hole and the black hole later evaporates through Hawking radiation, what happened to the information? Because it went in and it sort of comes out, it has to come out. Those are two incommensurate things. So the theory has been developed that we may be, that the information may actually never go into a black hole. It may be encoded on the surface. And in that case, well, that's too complicated a discussion to go into without my notes. But many things, anyway.
When you say
we'll discuss it again when I have notes.
when you say information, are you talking about all the protons, all the neutrons, all the atoms that are they on the surface?
There is a theory that the ultimate, well, information means a certain thing in physics, and we'll have to discuss that. That's a good topic for future.
Well, tell me this, these jets that are there, isn't that similar to the pulsars, the spinning white dwarfs or neutron stars?
It's similar, yeah.
Okay.
This is just more so.
Just much more powerful.
Yeah.
Would it be safe to say that virtually every object in the universe, all the stars and black holes are spinning? Nothing's sitting there solid and not moving? At
It
least
would
not-
be an incredible coincidence of groups to all have a net zero angular momentum. So I think you're pretty much going to have everything have some rotation or spin of its own.
Okay, and Jupiter, as big as it is, gets 10 hours.
Something spun Jupiter up.
Okay, what do we got here, sir? I think I remember.
Let's see.
Double
Where,
cluster.
All right.
Oh, the double.
yeah.
Okay, bright moon now, but it's waxing or waning. It's waning. Short view.
Yeah. We just passed full moon.
Yeah,
Okay.
full moon, I think, was Friday, Ron.
Okay, Perseus, my hero, or me, Perseus, the hero, is high in the east. Constellation is famous for its double cluster. You want to show us that? Is that the red?
This is the double cluster here. It's located between Cassiopeia, and this is an irritating thing of my software that it adds these three red lines to an otherwise easy asterism to see. A W there.
The W, yeah.
Yeah, that's Cassiopeia. And you can spot it easily with the naked eye on a dark site, on a dark night, between Cassiopeia and Perseus down here. So
And
there.
Ron, these red circles that you see, that's a simulation of the circles you would see in one of those Telrad finders like we were talking
Right.
about on the cartoon.
Oh, yeah, good point. Yeah.
Yeah, good point, Chuck.
Can't see those through your lens. It doesn't give them to. Why wouldn't they just show it to you on the lens that you're looking at?
So Ron, what happens is with these finders, these Telrad finders, it projects sort of at infinity, a bullseye that looks like that. So if your scope is aligned correctly with the Telrad, you've got it right in the eyepiece.
Okay.
Yeah, this is what you would see without all the red lines and labels.
Right. And I think the innermost one might be, a degree, right, Chuck? And the
I
outermost.
think it's half a degree, 1 degree, and 3 degrees or something.
Okay.
Joe would know, and Tim.
Tim, yeah. And I
And
have a whole bunch of
Tim's been
charts. I
texting.
was going to say, I have a whole bunch of charts I bought some time ago by a fellow up in, I think, Ogden, Utah, who basically had you go from NGC object or Messier object to the next with these little circles, They're really convenient, Ron. Okay.
Well,
Some
now
of the old star charts, when you had paper star charts, would come with a see-through template that had these circles, so you could superimpose them on the map
Yes.
and
Yes,
figure
you still-
out how you wanted to move your scope.
Yeah.
Chuck, guess who still has those? I do.
So
So anyway, this is in the part of the sky near the Andromeda Galaxy, M31, which you can see down here. And
below Cassiopeia.
There we
There
go.
we go.
this is a picture of the double cluster. You can see the two, that they're two open clusters. And this one is got some red giants in it here. And if you look at this double cluster before the sky is completely dark, it's bright enough that you can find it easily. The slightly non-dark sky emphasizes these red stars, and they kind of stand out at that time. It's a very pretty cluster. It's one of my favorite objects, and I guess Bruce says it's one of his too. He sent me a picture that's exactly like this picture, but I showed this one because I took this one and he took the other one.
Yeah.
So,
That red star that's kind of in the middle of the two is sometimes really intensely red.
Yes.
Farther up, between the two, kind of. Yeah, right there.
yeah. Okay.
They're half a degree apart, and they're both NGC numbers, right?
Yeah,
869 and 884.
Yeah.
So I was just going to mention the last Westmont Star Party. Tim was working with me up under the dome and trying to avoid the oil. But he knows a lot about this double cluster, and he was telling the folks who came to the eyepiece all about these red giants. Tim's really well informed about these objects. It was fun having him there with me. I learned a lot.
Tim is always fun.
Right.
Well, can we go from this to the hares cluster? Is that nearby? Or is that pronounced Harry's?
Well, no, that's hares, but that's just that's not any kind of official name. That's just a title somebody stuck on it.
I stuck that on there, the
Yeah,
hair
yeah.
cluster, because it's in the Lepus, the hare.
Lepus
Yeah.
the hare.
You left out an apostrophe for the hare owning it.
Yeah.
But
So
Lepus
this is the finder chart for that. Here's the Orion up here. You go down, not a lot of bright stars down here. There are a lot of bright stars in the winter sky. I think most of the bright stars are in the winter sky for us in the north. This is M79 right here, directly under south of Orion. And over here is Sirius, the brightest star in the sky, part of the big dog.
Orion the Hunter is in the.
Oh, there's a picture of Pallas asteroid
Yeah.
on this date, 7
And the-
o'clock.
And the Witch Head Nebula is showing up there by Rigel.
There's an asteroid in this picture.
Yeah, this red thing right down here.
It's not a picture, Ron. It's just a,
Oh,
Yeah.
screenshot.
This is a computer generated plot, and it shows it's how I generate finder charts for when I want to do star hopping. And it's called a planetarium program. Same type of thing that projects the patterns on the planetary ceiling, except this does it on your computer screen.
Lepus is one of the the constellations that I use to determine how good is the seeing, because it's just below Orion.
Yeah,
And some nights you can see it.
okay.
Other nights you can't. It's the atmosphere is just not cooperative.
And Tim's also pointing out that there's a really cool, very red carbon star there just to the right of Lepus, or the right of the stick figure. It's still in Lepus, but it's Heinz Crimson Star.
Oh, yeah.
Well, if it's
And here's the nebulosity you pointed out next to
The
Rigel.
Witch Head, yeah.
The Witch Head, yeah.
well, if we don't call the cluster the hare, is it called Messier 79?
No,
Yeah.
well, that's the globular cluster. Yeah.
M79.
That's a globular there.
Oh,
Right.
The constellation is Lepus the hare, but within it is this globular M79.
Right. So there's M79. This is M79 close up, the big scope.
Yeah.
Lots of red giants around, nice color.
Beautiful.
Yeah.
Amazing. Just dancing away with each other.
Yeah.
Well, I think you should have that patented or copyrighted as hares.
That is copyrighted, I think, but not by me.
Okay. Clusters are us. There's a lot of clusters. We used to have variable stars every week, but now it's clusters.
Well, was
No,
it once a
once.
month?
Yeah. And we will have those again.
Okay.
This is a close-up of a planetarium program, the Sky X. The follow-on to the one I use, the Sky 6. I have the Sky 6 on one computer and the Sky X on my other computer. So this is Comet E3, and this is on January 12. So which is at perihelion to the sun for this comet. I understand this comet will be the brightest that it's going to be on in early February. I think it's about just on the edge of visibility to the naked eye now.
And that's as close as it's going to get to the sun.
Yes,
Yes.
which is about 1.1 AUs. So,
And it'll go back out into the Oort or the.
yep.
No, it's a real long, well, yeah, it's a real long period comet. This is a poor photograph of it.
It's estimated to be like a 50,000 year period.
Right.
50,000
So
years.
last time it was here, the Neanderthals were looking at it.
Are you kidding me? Really? And it's not on the ecliptic, it's cutting through just like Oumuamua did, except.
Cutting through the plane, yeah. So it's a very nice comet with two tails, two very distinct tails, one dust, one ionic.
Which one is the ionic? The one that
Thin one on the right.
Yeah, the one that
Oh, the
doesn't
long,
curve,
skinny one. Okay.
the one that does not curve.
Yeah.
Well,
Well,
which
the other one is all kind of diffuse.
Well,
Well,
it's
it's
fan
also
shaped. Yeah.
It's curving too.
Which
It's
one is,
curving. It's following, it's particles, heavy particles
Right.
They follow
being
the
affected
orbit.
by gravity, whereas it's these really light ions being pushed by the solar wind form the straight sail.
Right. That's exactly it. Yeah.
got it.
Who shot this, Jerry? It's
This I
nice.
don't know. It was, I found it on the
Space
web.
weather?
What's that?
Is it on space weather? It looks like one that was on there.
It could be. It could be. But
Didn't you shoot this and didn't it appear in Ed Hat?
I did not
Yeah.
shoot these.
I did, but I couldn't pick up the ion
Oh.
tail.
Yeah.
Okay.
Chuck did. Yeah.
Okay, the only thing that changes in the names of these suckers is that number next to E. Was there an E2 last year?
Yes.
It would have been, yeah.
Okay, well, would that have been the Schwarzman?
No. Schwarzman Walkman, we've known about for a long time. So it actually was before they came up with this designation. They've probably given it a similar one.
Yeah.
Basically, it's C for comet, and then the year, and then the alphabetical character is which 2-week period in the year in which it was found. And then the number is where in that 2-week period, which one sequentially it was that was found. So that was the third one found in E, which is March. And then, or the second half of March, something like that.
Mm.
And then the ZTF in parentheses is that it was found by the Zwicky Transient Facility.
And any they find this year will be C/2023.
Yes.
Okay, and then did they start over after that, E1, E2, or did they change
Yeah,
the?
yeah. A for the first week of the month, B for the second week of the year, C for the third week of the year, or 2-week period. I'm sorry, 2-week period.
Yeah, that's a numbering system that has come on in modern times when we got very good at finding things, and it just swamped us. In the early days, it was a great honor to have something named after you. They named it after famous people if they wanted money from them. Like I think one of the Herschels wanted to name Uranus when he found it. He wanted to name it after King George.
Yeah.
I remember correctly, and there was a big fight, so they settled on Uranus later. But now we see in comets, we see so many of them, we have to go to this numbering system now.
Yeah, and Schwarzman Walkman was the two astronomers that first saw that one. But
Right.
nowadays they're found by things like ZTF, and so they get that ZTF
Right.
tag.
Well, if you're telling us, as you did a moment ago, that this sucker goes around the sun, 50,000 years in an orbit? Is that what you said?
That's the
I
estimate.
think
Yeah.
it is, yeah.
Why wouldn't we be seeing this thing for hundreds of years up there then? That's a little arc of its orbit, wouldn't it?
Yeah, but it goes so far out and it's so dim, you can't see it. We can follow it a lot farther now.
Anything in its orbit follows Kepler's equal area and equal time thing.
Right.
And if you have a apogee that is so far away, the comet is traveling extremely slowly out there. And then when it whips in close to the sun like that, it's really going lickety split. So they're not here for a long time. They're out there for a long time. You can look up Halley's Comet, and you can find current pictures of it where it is now through large telescopes.
Okay.
That's because it has a much more circular orbit, and so it's not
Right,
not going way far out.
right. But it's still
Mainly the
elliptical.
fact that it's not far out.
Huh. Fantastic. We've got about 6 minutes to cover wetness on Mars and a scary magnetar, Mr. President. Back to
I
Mars.
think the Mars will be enough.
Okay.
So this is a picture of Mars, and the article I read talks about fissures, and they're looking for water. And apparently the fissure, and this is an example of it, which they marked it kindly because I don't see a fissure, but this fissure has a bright border to it. And through spectroscopic analysis of the border on the rovers, one of the rovers, they've decided that this is opal and a mineral of opal. And opal forms in this kind of terrain with water. It interacts with water. And so this is indirect evidence of ancient water on Mars. I think this is in Gale Crater, if I remember. Let me check my notes.
Anybody know what month of the year is opal?
Oh,
It's a good one, you know?
yeah, this is Gale Crater.
They find it in Australia a lot.
Yeah,
Yeah. And this was from the Curiosity rover.
Okay.
The results were reported December 19 in the Journal of Geophysical Research, Planets.
some real slate strata there.
Mm-hmm.
Interesting. So Mars had oceans probably.
Certainly had very large lakes, apparently, yes.
Tim is pointing out that today's astronomy photo of the day is comet E3ZTF.
Oh,
And it's the ion tail is bifurcated. So now it's kind of V-shaped. There's a pair of them, a pair of the streamers.
Bifurcated, the new word.
Whoops, I hit the wrong thing.
Was disconnected us. It's still raining.
Yes, you see.
Mars was wet.
I thought
I have a couple of skylights in my office, and when it's raining like now, it just sounds like thunder in here.
yeah,
Okay, this was the Curiosity and the Gale Crater, right?
yes, this is Gale Crater, and it's taken by Curiosity. And I find it interesting. There's these little landslides here, and over here it looks like you can see the dark material moving down,
mm-hmm.
which and it's in a number of places, and I think these are dust slides. I don't think it's water, but there was a discussion several years ago about whether these were water.
Mm-hmm. Like a debris flow, huh?
Yeah.
Mm-hmm.
And this one, it looks like there's a big plate that's sort of losing its grip on things and sliding down, sort of a landslide.
And a nice sinuous little ridge there in the mini dust dune right near where that slipping bit was.
Here?
Yeah, to the left there, that whitish sinuous line going down looks like it might be the rim of a little dune.
Yeah, it does look like that.
Yeah. Choptail Pat, it looks like a chocolate bark to me.
Now the same thing that the human mind spots asterisms in star background, star pictures, leads them to find strange objects that really aren't there in pictures with a high degree of detail like this. For example, this looks to me like a trout with the fin and the tail.
Oh, that's one of those sharks.
Yeah. So, but this is not a fish on Mars. I don't want to start a religion here.
Way down on the right too, not way down, but there you can see where there's right there, just below your cursor, below and left, you can see there's a little tongue sticking out that's going to break off one of these days. You can see how it's casting a shadow. So it's just kind of a plateau,
Oh, this.
a little patio. No, down farther, just
Yeah,
below, right
Oh,
there.
that, yeah. Oh, you've done it now.
Yeah.
Well, do you suppose science fiction writers have been having a field day about finding bones of strange extraterrestrials, either in our past, looking for dinosaur bones, something metallic that crystallized 60 million years ago, or even on Mars from one of these rovers?
Oh, that's been done a zillion times since I was a kid. I've read about things like that. The best one was that they made into a movie, and it was an idea that actually I had in the back of my head for a science fiction show, was one where they go to Mars and they find this large dome, and they go in the dome, and it's actually a planetarium. And it shows people, there's no people around, but it shows a video of something happening on Mars, and then all these spaceships going from Mars to Earth. And God, I forget the name of it. It wasn't too long ago. It was in the 90s or something. And it was starring Sinise. What's his first name?
Gary Sinise.
Gary?
Gary Sinise, yeah. And he was the guy that elected to stay behind on Mars because he wanted to see how the movie ended. And everybody else made a dash for the return, vehicle. So,
As opposed to the Matt Damon wearing his own.
no, that was an interesting movie, the Matt Damon one, but I just couldn't get past the fact that that when his domicile on Mars lost its fall, he put up a sheet of plastic, and that kept the atmospheres separate. But the pressure difference would be so incredible. There's no way he could do that.
Yeah.
So every one of these things usually has some little fault in it that just I have trouble looking past. So if not for this, the movie would be great. So
I didn't see it, but I heard he grew potatoes or something inside with his own poop as
With
fertilizer.
everybody's poop from the previous mission. Yeah.
yeah.
And he's written a couple of others, and they're all science-based. One of them's called Artemis, and it's about a future colony on the moon. And another one is called the Hail Mary mission or something like that. And it's about finding another civilization out there and how you would try to communicate with it using mathematics and things like that. They're all a little fantastic, but he tries to base it as much on science as possible. Andy Weir.
Okay.
And
And
Artemis.
there was a scientist a colleague of mine that I knew out at the research labs called, oh God, I forgot his first name, but his last name was Forward. And he was a research scientist at Hughes Malibu, and he also wrote science fiction. He's got a number of very good science fiction books that are science-based.
But is my understanding correct in Artemis and Apollo were two cohabitants in Greek mythology? They were together?
I think brother and sister.
Brother, and that's pretty close. Well, you regaled us, Mr. President, as usual. And the rest of you, thank you very much. We seem to have lost a spam filter. That would be Mr. Bruce. He also there you are. He's on the telephone. He's president of the Santa Barbara Theater Organ Society. I assume they're opening up too. And we'll have our next meeting in February on the 3rd, I think. We just had a grand time and a great speech from Chuck about occulting. And we'll do this every Monday morning, I guess, through the year 2023. Take care of your wives, gentlemen, both Pats and Maureen. And good luck in the rain, and I hope you have flood insurance. We'll see you next Monday morning on the Astro.
Bye.